Okay, so now we're going over to section, again, a quick review. Section 1.2, which is simply adding whole number expressions, so no decimals or anything, we're just adding whole numbers. So for each one of these, we're going to go over adding, subtracting, multiplying, and dividing. For each one of those, we're going to start getting you ready for some story problems. Story problems, a real story problem really doesn't happen for a few chapters, but they do a good job of getting you ready for those things that are going to happen. So for example, it says translate each English phrase. Basically what you're doing is you're translating it from English to algebra. So we're going to use numbers and symbols. When we talk about symbols, what we're going to do is we're going to do plus, minus, divide, or multiply. And then we're going to use a variable. Now we can use any variable we want. I'm going to choose to use the variable n standing for a number. So if I want to translate a number plus 2 into algebra, a number would simply be n, and then I'm going to add 2. So it would simply be n plus 2. That's all they're looking for. So when you see the word plus, it obviously means this symbol. If I want to translate 12 more than a number into symbols, more than, again, would mean addition. So that would be 12 more than a number, and again, I'm going to use n for my number. You can use x, you can use anything you want. Okay, so again, more than would mean addition. Look at number 2. Express the number 8 as the sum. Now you should know that sum is a word that always means the answer to an addition problem. So express 8 as the sum of two whole numbers. Write all of the different possibilities. And I have a reminder for you here. When we talk about whole numbers, these are your whole numbers. No negatives, no decimals, no fractions. So if I want to express 8 as the sum of two whole numbers, I think you should be able to see that 0 plus 8 would be the sum of two whole numbers, and in this case I would get 8 as the answer. I'm going to do this in a very organized way. I hope you can see that if I could do 1 plus 7, that would give me the sum of 8 as well. I would do 2 plus, but you can guess it, it's going to be 2 plus 6. That has a sum of 8. 3 plus 5 is a sum of 8. 4 plus 4 has a sum of 8. Now, you may think that that's it, but notice it says write all the possibilities. So another possibility is actually 5 plus 3. Yes, I know that it looks like this. Actually, it's flipped, so we're going to use that as a different possibility. Just like we're also going to use 6 plus 2 as a different possibility than 2 plus 6. We're going to use 7 plus 1, and we're also going to do 8 plus 0. So those are all the different possibilities of ways from the whole numbers to get a sum of 8. So now let's talk about the fact that actually these two mean the same thing. There's a special property that tells you that, and it's called the commutative property for addition. And what the commutative property says is, it basically says that it doesn't matter what order you add two numbers in, you're going to get the same answer. So a plus b is exactly the same as b plus a. If you do 10 plus 5, it's exactly the same as 5 plus 10. So there's an example for you. So now let's use that commutative property, and that's not going to be the only property we're going to have. It's just the first one. This one says rewrite this expression x plus 3 using the commutative property. So all it's telling you to do is change the order. So in other words, the answer to this one would be 3 plus x. We rewrote it, but we just flipped them. We used the commutative property. So that's example 3. Look at example 4. This says if 190 plus n which is any number or a number, is equal to 532, then what is n plus 190 equal to? Well, I hope you can see that if I look at the left-hand side of the equal signs, don't they mean exactly the same thing? From the left here to the left here, we've just switched the order. So they mean exactly the same thing, which means that that also has to equal 532. So commutative property is your first property. That's an order. If you're using commutative property, it means things have changed order. The second property we're going to talk about is the associative property of addition. And if you go back to your English background, hopefully you remember that the root word of associative is associate. Associate. In other words, who are you grouped with? The associative property of addition is the grouping property. In other words, if you look at this example here, notice on the left-hand side, I've grouped the x plus y together. And on the right-hand side, the y plus z are grouped together. Now notice nothing has changed order. The order is exactly the same from left to right. So there's no commutative property happening. It's just being regrouped, which is your associative property. If you wanted to throw in some numbers here, you could say that 2 plus 3 plus 4 is exactly the same as 2 plus, and let's regroup, 3 plus 4. And hopefully you can see that if I were to add these first, 2 plus 3, that's 5. Add 4, I would get 9. If I went to the right-hand side and if I added 3 plus 4 first, that's going to give me 7. And then when I add the 2, I'm still going to get 9. So it really doesn't matter how they're grouped. So let's use that for number 5. Use the associative property of addition to rewrite the sum and then simplify. So if I want to do some regrouping here, I'm going to group not the y and the 4 together, I'm going to group the 4 and the 2. So if I'm just going to use my property, I'm going to regroup them, which means I'm going to group the 4 and the 2 together. Now that the 4 and 2 are grouped together, I can simplify the set of parentheses because I know 4 plus 2 is equal to 6. All right, let's look at number 6. Now notice the directions for number 6. It says use the associative and or commutative properties to simplify. So we are actually going to use both. So here's the idea here. What you want to do is you first want to use your commutative property and rearrange things a little bit. And the way you want to rearrange it is you want all of the numbers in a row. Here's what I'm talking about. So if I look at this, do you see where all of the numbers are not in a row? There's a z in the middle there. So what I'm going to do is I'm going to first use my commutative property because I'm changing their order, and I'm going to flip-flop the z and the 3. And when I do that, it's going to look like this. And the reason, again, I did that is because I wanted all my numbers in a row, which they are now there. Now what I want to do is I want to use my associative property, which means I want to regroup. And when I do that, what I'm going to do is instead of grouping the 8, the 3, and the z together, I'm going to group all of the numbers together. When I write a z, I put a little mark through there, so just so you know that. And now the idea is because now I have all of the numbers grouped together, I can go ahead and I can add them together. So 4 plus 8 is 12, plus 3 is 15, plus z. And there's the simplification. Okay, so that idea is going to take you a little bit of practice. We're not quite done with the section 1.2. Again, it's a quick review. So if we look at number 7, it says evaluate m plus n plus 7. Okay, so that's the expression we're going to evaluate. I actually have a word for what we're about to do. I call it plug and chug, because here's what we're going to do. For A, we are told that M is 3 and N is 1. The first thing we're going to do is I'm going to go up to this expression. I'm going to plug in the values they give me. So they tell me that M is 3. So instead of an M, I'm going to write a 3. Plus, they tell me that N is 1. So instead of an N, I'm going to write a 1. So I've plugged in the values for the variables. And now I'm just going to chug out the answer. 3 plus 1 is 4, plus 7 is 11. Plug and chug. Let's do this one over here. What I would like you to do is, why don't you turn off the video, do this one on your own, and then come back and make sure you have the answer correct. So if I go up into this expression again, but this time I'm going to plug M is 5. So wherever I see an M, I'm going to put a 5. Wherever I see the N, I'm going to put a 10. So there's my plug step. I plug them in, and now I can chug out the answer. 5 plus 10 is 15. And then 15 plus 7 is, of course, 22. All right, so let's review addition here. So again, it doesn't matter what order we add them in. So we're going to first of all write my 3 numbers vertically. We'll put the 249. Now I'm going to put the 389 first. And again, it doesn't matter, but I just like my longer and distance numbers to be above. And again, it doesn't matter what order you add them. All right, so let's quickly review addition. So if I go ahead, I'm always going to start in the right-hand column. And if I add these 3 numbers going down, 9 plus 9 is 18, and 18 plus 5 is 23. So what I do is I put down the 3 from the 23, and I carry the 2 up there, and that gets added into this column of numbers now. So 2 plus 4 is 6, 6 plus 8 is 14, and 14 plus 7 is 21. I put down the 1 and I carry the 2. Now I'm going to go ahead and add these numbers. 2 plus 2 is 4, plus 3 is 7. So my answer is 713. Okay, so there's a quick review of addition. Now let's use it. Let's talk about perimeter. I want to find the perimeter of this figure. Perimeter means distance around a figure. And what you do to find the perimeter is you add all sides. So since this is a rectangle, we know that this side is 7, this side is 3. That side is also 7 because opposite sides are going to be the same. And this side is 3. So I'm going to find the perimeter. I have to add 7 plus 3 plus 7 plus 3. There are 4 sides, so I have to have 4 numbers here. So if I add them together, 7 plus 3 is 10. 7 plus 3 is 10. Doesn't matter what order I add them. You can see 10 plus 10 is 20. So my perimeter is 20. Don't forget to label your answer 20 inches. Look at number 10. Now notice I only give you one side. Hopefully you can see that that looks like it's a square. And what do we know about all the sides of a square? Well, they're all the same, which means all 4 of the sides are 15. So to find the perimeter, I'm going to add 15 plus 15 plus 15 plus 15. So I'm going to add these 2 together to get 30. And then I'm going to add these 2 together to get 30. Now again, you could just go from left to right and keep adding. That's all the same answer. The way I did it, I'm going to get 60. No matter how you do it, you should get 60. And in this case, it is 60 feet. Okay, let's go ahead and do this last one. Now, this is kind of a weird looking figure. First thing I have to say to you is, first of all, this is not, this side kind of scratch it off if you want. That side is not actually part of the perimeter. Your perimeter is the distance around the edge here. So you can see, since that is a middle, that is not part of the perimeter. But if you look, if I start up here in this corner, I know this is 8, this is 13. I do not know this side, or do I? Well, if you look at this bottom figure, you should be able to tell that that's a square, which means that that side is 5. Now I know this side. I know this side from here to here. Technically, I don't know this length right here, but actually I do. It's the same as this guy over here. So it is 8. Now, how about this guy up here? I'm not given that length. But if you look carefully, you can see that length. I can break it apart. It's actually the same as this length plus this length. So you can see that it's going to be 13 plus 5, which is 18. So now I know the lengths of all the sides. So I'm going to start here, and I'm going to go around, and I'm going to write all the sides. So I'm looking at 18, then I have an 8 and a 5. So that takes me down to here. I have 5 and 5. And then I have a 13 here and an 8. And I'm going to add all of these numbers up. So I'm just going to go down. 8 plus 8 is 16. Plus 5 is 21. Plus 5 is 26. Plus 5 is 31. Plus 3 is 34. Plus 8 is 42. Carry the 4. So 4 plus 1 is 5. Plus 1 is 6. So the perimeter of that weird looking figure is 62 meters. And we're done with 1.2.